For most of human history, the stars were just distant points of light. They were beautiful, mysterious, and seemed impossibly far away. We looked up at the night sky and saw constellations telling stories about gods and heroes. Our own solar system felt special, a unique island of worlds orbiting our sun. We knew of Mercury, Venus, Mars, Jupiter, and Saturn. These were our neighbors. But beyond them, we imagined an empty, silent void. The idea that other stars might have planets of their own was mostly confined to science fiction stories and the bold dreams of a few thinkers. We were a small blue marble in a seemingly endless dark. The desire to find other worlds is a fundamental part of the human spirit. It is driven by the same curiosity that pushed our ancestors to cross oceans and explore continents. We have always wanted to know what lies beyond the horizon. How many planets are there in our galaxy? A star like our sun is 1 billion times brighter than the light reflected by a planet like Earth. Scientists proposed an idea called the transit method. If a planet passed in front of its star from our point of view, it would block a tiny fraction of the star's light. One of the key figures was William Barucki, a scientist at NASA's Ames Research Center. For decades, Barucki was driven by a single powerful idea, that we could find Earth-sized planets by watching for their shadows. Most of the astronomical community was skeptical. Barucki and his team refused to give up. They built prototypes in their labs, ran simulations, and methodically solved each problem. Finally, in 2001, their proposal was accepted. The mission was named Kepler, in honor of the 17th century astronomer Johannes Kepler, who discovered the laws of planetary motion. Just as the original Kepler had revolutionized our understanding of our own solar system, this new Kepler was poised to revolutionize our understanding of the galaxy. Building the Kepler Space Telescope was a monumental feat of engineering. Its most important component was its photometer, a massive digital camera. It was the largest camera ever launched into space at the time, boasting 95 megapixels. So, engineers placed Kepler in a unique Earth-trailing orbit around the Sun. It slowly drifted away from our planet, maintaining a clear and stable view of its target stars. The team chose a small patch in the northern sky, located within the constellations of Cygnus, Lyra, and Draco. For its entire primary mission, Kepler's gaze would be fixed on this one spot, an area of the sky no bigger than the size of your hand held at arm's length. The mission officially began on March 7, 2009, when Kepler was launched aboard a Delta II rocket from Cape Canaveral, Florida. On May 12, 2009, Kepler started its science operations, collecting what scientists called first light. The data began to stream back to Earth, and the science team prepared to sift through it. The algorithms began their tireless search, looking for the faint, repeating dips in starlight that would signal the presence of a planet. The first results were announced in early 2010. The team revealed the discovery of 5 new exoplanets. These were not the small, rocky worlds they were ultimately searching for. They were all hot Jupiters, large gas giants orbiting incredibly close to their parent stars. One of them, named Kepler 7b, was one of the least dense planets ever found, with a density similar to styrofoam. While these were not Earth-like worlds, their discovery was a monumental achievement. It proved that the Kepler telescope was working exactly as designed. As the months turned into years, the trickle of discoveries turned into a torrent. In February 2011, the team made an announcement that stunned the world. They released data on 1,235 planet candidates. The sheer number was honestly breathtaking. The diversity of these candidates was just as shocking as their number. The data revealed worlds of all sizes and orbits. The team identified 68 candidates that were roughly Earth-sized. And most excitingly, 54 of these candidates were located within their star's habitable zone. This was the first statistical evidence that small, potentially rocky planets in the Goldilocks region might not be rare at all. One of the most surprising discoveries was the abundance of worlds with sizes between that of Earth and Neptune. These planets, now called super-Earths or mini-Neptunes, turned out to be the most common type of planet in the galaxy. It discovered compact systems, where multiple planets orbited their star much closer than Mercury orbits our Sun. It found planets orbiting binary stars, worlds with 2 suns in their sky, just like Luke Skywalker's home planet of Tatooine in Star Wars. The galaxy was a far more creative and chaotic place than we had given it credit for. This bonanza of planets provided a statistical foundation for understanding planet formation. For the first time, scientists had a large sample size. It transformed our view from a galaxy of lonely stars to a galaxy of stars with families, a galaxy teeming with worlds waiting to be explored. In December 2011, the Kepler team announced the confirmation of Kepler 22b. This was the first planet Kepler found that was squarely in the middle of its star's habitable zone. The star itself was very similar to our Sun, just slightly smaller and cooler. It was orbiting its star at a distance that could allow for temperatures suitable for liquid water, the key ingredient for life as we know it. There was Kepler 186f, the first Earth-sized planet found in another star's habitable zone. Then came Kepler 452b, described as Earth's older, larger cousin. It orbited a star very similar to our Sun, and had a year that was 385 days long. For the first time, we could point to a specific star in the sky and say, right there, orbiting that star, is a world that could have oceans. One such story is that of Natalie Batalla, a key figure on the Kepler science team. Her journey with Kepler was one of deep personal and professional commitment. For Batalla and her colleagues, every new planet candidate was more than just a data point. It was a potential new world, a new piece of a grand cosmic puzzle. One of the moments that stood out for Batalla was the discovery of Kepler 10b. This was the mission's first confirmed rocky planet. Batalla had described the moment the team realized what they had found as a turning point. It was the first step on the path to finding a true Earth twin. One of the most iconic images from the genre is the double sunset on the desert planet Tatooine from the film Star Wars. For decades, this idea of a planet orbiting two stars seemed like pure fantasy. But in 2011, the Kepler mission turned this science fiction dream into a scientific fact. The team announced the discovery of Kepler 16b, a planet that orbits a pair of stars. They had found a real-life Tatooine. The number of possible homes for planets in the galaxy suddenly expanded dramatically, all thanks to this one incredible discovery. In May 2013, after 4 years of unprecedented success, disaster struck the Kepler mission. The telescope lost its ability to aim. For the science team, it was a devastating blow. The planet-hunting machine had been crippled. Engineers on the ground began working on an ingenious solution. They realized they could use the gentle pressure of sunlight itself as a kind of virtual third reaction wheel. This resurrected mission was named K2. Instead of staring at one patch of the sky, the newly stabilized Kepler would now point at different fields along the ecliptic plane. The K2 mission was a stunning success. It went on to discover hundreds more exoplanets, as well as observing supernovae, asteroids, and comets. Kepler's second act proved to be just as fruitful as its first, adding even more worlds to its already incredible tally. Not all of Kepler's discoveries were made by professional astronomers. They launched a project called Planet Hunters, a citizen science initiative. This project brought tens of thousands of volunteers into the heart of the scientific process, turning ordinary people into partners in one of the greatest explorations of our time. In 2012, 2 volunteers, Kian Jek and Robert Gagliano, flagged a strange light curve that showed a complex pattern of dips. The planet, named PH1b for Planet Hunters 1, was a gas giant orbiting a pair of stars. Before Kepler, our model of the galaxy was star-centric. We saw it as a grand collection of suns, with planets being a rare and perhaps accidental byproduct. The new model of the galaxy, informed by Kepler, is one where planets are not the exception but the absolute rule. The data suggests that, on average, there is at least one planet for every star in the sky. Look up at the night sky, at the countless points of light. We now know that almost every single one of them is a sun with its own family of worlds. The Milky Way is not just home to 200 billion stars, it is home to hundreds of billions, perhaps trillions of planets. We are not living on a lonely island. We are part of a vast cosmic archipelago of worlds. The new map shows a galaxy that is far more crowded, more interesting, and more vibrant than we ever dared to imagine. After analyzing the full dataset, astronomers have been able to make a robust estimate. The current calculations suggest that about 1 in 5 sun-like stars has an Earth-sized planet in its habitable zone. It means that the nearest potentially habitable Earth-sized world could be orbiting one of our closest stellar neighbors, perhaps just a dozen light-years away. It suggests that there could be tens of billions of potentially habitable worlds in our Milky Way galaxy alone. The galaxy is practically overflowing with real estate that has the basic requirements for life. The first of these is NASA's Transiting Exoplanet Survey Satellite, or TESS. Launched in 2018, TESS is conducting an all-sky survey. This is where the next great observatory, the James Webb Space Telescope, comes in. The Webb telescope is the most powerful space observatory ever built. As the planet transits its star, a tiny fraction of the starlight will pass through its atmosphere. Webb can analyze this light, breaking it down into a spectrum. On October 30th, 2018, after 9 years of revolutionary discoveries, the Kepler Space Telescope finally ran out of fuel. NASA sent the final commands to retire the telescope, leaving it to drift forever in its peaceful orbit around the Sun. It was a poignant end to one of the most successful science missions in history. Before Kepler, we looked at the stars and wondered. Now we look at the same stars and we know. We know they are not just lonely points of light, but distant suns, most with their own families of worlds. It reframes our relationship with the cosmos, transforming it from a vast, empty expanse into a grand, crowded stage filled with potential. Kepler provided the statistical proof we needed to redraw our map of the cosmos. We are citizens of a crowded, vibrant cosmos, members of a galactic community of worlds whose other inhabitants we have not yet met. The era of Kepler the telescope may have ended, but the era of Kepler the idea, the quest to find our place among the worlds, has just begun. The search continues, driven by the legacy of a small telescope that dared to stare into the abyss and found it staring back with the light of 1 trillion planets. The silence we once heard from the stars has been replaced by a whisper of possibility, a promise that the greatest discoveries are still yet to come. Our universe is waiting,